In this video, we're looking at what's known as conditional probability. This takes place when we have two events, and the probability of the second event occurring will depend on the outcome of that very first event. Now we're going to look at an example that's a little bit more challenging in a minute, but before we get to that, let's look at a basic example. So imagine I have, say, 5 beads. I've 2 blues and 3 greens. So I'm just going to draw out my 5 beads here. Now the probability of me picking a blue bead is the probability of blue, which is equal to 2 out of 5. So that's basic enough. The probability of picking a green bead is 3 out of 5. So they're the two probabilities of each happening. Now imagine the case where I pick out a blue bead. So I've assumed that I've picked that blue bead. Now what I'm going to do is, with the remaining beads, I'm going to carry out an event again. I'm going to pick a bead out. But remember now that I only have 1 bead left in the pack and my 3 green beads. So the probabilities are now changing. The probability of picking a blue is now 1 out of 4. In my first event, it was 2 out of 5. And the probability of picking a green has now changed, not from 3 over 4, which would have been 60%. It's now changed to 3 out of 4, which is 75%. So see how you picking out a bead in the second event has been impacted on the outcome from the very first selection. And this is what's known as conditional probability. Me picking out that blue bead is dependent on the color that I pick on the first go. So up at the top here, I have just written down the formula that you're going to need. So to keep this in mind, and it's pronounced as the probability of A happening given that B has already happened. So this little symbol here is standing for given that. So it's the probability of A happening given that B has already happened. And just have a look at our examples down there with the colored beads. And in order to find the conditional probability, what you do is you get the intersection of the two events, and then you divide it by the probability of the event that has already happened. Okay, so let's have a look at a more challenging example. So in our example here, we're looking at the population consisting of males and females who are studying both arts and not arts. So you can see how it's broken up. For instance, we have 25% of the population are females who do not study arts. So if you add those 4 probabilities together, you get 100% representing all of the pupils in this particular college. So looking at our first example there, the giveaway word to these questions is the given part. So anytime you see given, you should all automatically be thinking conditional probability. So first of all here, up the top, I'm just going to write down the formula that we looked at. And it was the probability of A, given that B has already happened, is equal to the probability of A intersection B all over the probability of B. So that's the formula that we will need throughout all of this question. Now, obviously, my A and B are going to change for A and F, arts and female. So look at the first one here. What's it saying? We are picking a student at random, and given that the student that we pick studies arts, what's the probability that the student is also a female? So let's have a look at that one. So that's going to give us the probability of a female given that they also study arts. So that's my setting up of my probability. And that is equal to the probability of female intersecting with art. So in other words, the female also studies arts, and I'm dividing that by the probability of arts. Now it's important that you set it up correctly. There's a difference between probability of female given arts compared to arts given female. So we're going to look at that in part 2. Filling that in, what is the probability of females studying arts? Well, it's this 30% here, this first box. So I'm going to turn these into decimals. So that's giving me 0.3 all over the probability of arts. And what proportion of all the students in this college study arts? Well, it's 30 and 30, which is 60. And that is giving me, if I simplify that, to 1/2 or 0.5. So that basically means that the probability of picking a female given that they study arts is about, or it is 50%. Looking at part 2. A student is picked at random. If the student chosen is female, what's the probability that that student studies arts? Okay, so let's set it up again. So we are now looking at the probability of arts given female. So we're looking for the probability that the student studies arts given that they are female. And that is equal to the probability of arts intersecting female, or an art student who is female, divided by the probability of a female. So it's very similar to part 1, just look at how it is slightly different. And the probability of an art student being female is 30%. It's the same as up above. But now look at our denominator. Our denominator is now changing. It's the probability not of arts, but it's the probability of female. So what percentage of this population sampled is female? Well, it's the 30 and the 25. So that is 55% or 0.55. And if I simplify that as a decimal, I get 0.545. So that is basically telling me that 54.5% is the probability that we pick a student who studies arts given that they are female. Coming down now to part 3. Given that the student picked is female, what is the probability that this student does not study arts? So we're getting into the do not part here now. So let's set that up. So that's going to be the probability of not arts. So I'm going to use this little symbol that we would have used before as part of set theory with the A dash. That means not arts, given that the student is female. So what's the probability that the student does not study arts given that the student is a female? So that is now equal to and it's all divided by the probability of female, and the non-art students intersecting with female is 0.25 or 25%. So I'm going 0.25 all over the probability of a female, which is the 30% plus the 25%, which is 0.55. And if we simplify that, I'm getting 0.455. So the probability of a student not studying arts, given that the student is a female, is 45.5%. And our final part. A student is selected at random. Given if the student is a male, what is the probability that that student also studies arts? So the probability of arts, given that it's a male, so the probability of an art student, which is also male, is equal to the probability of arts intersecting with male, or a male who is doing arts, all over the probability of male. We come up to our table, and we are looking for arts and male, which is this 30% here that I've highlighted in yellow. So that's 0.3 all divided by the probabilities of male, and we have 30% of males and 15% who are the non-arts. We add them together, which is giving me 45% or 0.45, and that converts to a decimal of 0.667. And that is our conditional probability. Just remember, this formula at the top is vital. The probability of A given that B has already happened. Thank you for watching another tutorial video from Tulla Maths. Make sure and subscribe.